Hello guys, in this video we will be looking at the dissociation or ionization of electrolytes and equilibrium constant expression. The learning objectives of this video is one, to define what electrolyte is and to classify the types of electrolytes. The second one is we are going to learn about how to express the equilibrium constant for acid and base. So what is electrolyte? Electrolytes can be defined in terms of chemical expression and in terms of biological expression. The first one is you can define as electrolyte as it is a substance that conducts heat or electricity by the movement of the ions, or biologically you can define electrolyte as any substance in the fluid of your body that control or regulate how your body processes waste and absorbs nutrients like vitamins, minerals and the like. So in your biological concept, these electrolytes are any substance that control or regulate metabolic process. And another thing is the classification of the electrolyte. We can classify electrolytes based on their dissociation completion as strong electrolyte and weak electrolyte. Strong electrolytes are those electrolytes that completely dissociate to produce ions, and these strong electrolytes involve irreversible chemical reactions, and their chemical reaction is indicated by a single arrow, and these strong electrolytes does not form or do not form the equilibrium state. Whereas the weak electrolytes are those electrolytes that partially dissociate to produce ions, and they are indicated by double arrow, and these are the reversible chemical reactions, and these are the cause of the the cause of the weak electrolyte. For example, if you consider this chemical reaction from as you can see from here, this chemical reaction is indicated by a single arrow, so nitric acid can be considered as strong electrolyte because it is completely dissociated into positive and negative ion. Whereas if you consider this chemical reaction is a reversible reaction because it is indicated by double arrow. So because of this, acetic acid is considered as weak electrolyte. This is the concept of electrolyte and the types of electrolyte. Another thing is about the dissociation expression for water, acid and base. So what is equilibrium? As you have seen in the previous video, we said that equilibrium is established from the weak electrolytes and only from the reversible reaction. We can write the equilibrium constant for weak electrolytes, but dissociation constant can be written for both strong electrolyte and weak electrolyte. Generally, to write the equilibrium constant that is derived from the weak electrolyte, you can use this concept. Equilibrium constant is the ratio of the species or the concentration of the products divided by the concentration of the reactants. For example, if you consider the reaction of water, that is dissociation of water, this is indicated by double arrows. This chemical reaction is that of the weak electrolytes. So you can write the equilibrium constant of water as the concentration of the products, that is concentration of hydronium ion times concentration of OH ion divided by the concentration of water. But to express the equilibrium constant, we ignore those species that present in liquid form and in solid form. So in this case, water is presented in the liquid form, so you ignore the denominator. So you simply express equilibrium constant for water is the concentration of the hydronium ion times the concentration of OH ion. But do not put here plus B from here, so it is a multiplication here. Another thing is the equilibrium constant for acid and the equilibrium constant for base. Let us look it as follows. So equilibrium constant of acid and base is the equilibrium that involves acids and bases, and it is critically important for a wide variety of chemical reactions. How can you express the equilibrium of acid and base, and what does the magnitude of the equilibrium tell us? From here, after calculating the magnitude of the equilibrium, it tells about three things. The first is it is the measure of strength of acids and bases, and it is an indicator of the reaction completion, and it is an indicator of the direction of the equilibrium. Totally, the higher the equilibrium constant of acid or base, the stronger the acid and the base is, and the faster the reaction completion, and the equilibrium position is more towards the right hand of the reaction. That is, you can also state this vice versa. Generally, you can, as a ground rule or as a rule of thumb, you can say that for weak acids, we have small equilibrium constant of free acid, and for strong acid, we have a large equilibrium constant. And you can interpret this for bases similarly, and this is what the magnitude of the equilibrium constant tells us. Another thing is the ionization or equilibrium of the acid. And you can classify acids as strong acid and weak acid. Similarly, you can classify bases, strong base and weak acid. So strong acid versus weak acid. What is the basic difference between strong acid and weak base? As you can see from this diagram, if you consider this is a strong acid and this is strong base, after the dissociation at equilibrium, as you can see from here, there is a completely dissociation of the H plus and A minus, but from the weak acid there is some hydrogen ion and base, that is the negative ion that is dissociated, but here we have undissociated species of the acid. So as the presence of some of the undissociated acids, this chemical substance can be considered as weak acids. Similarly, you can see from this diagram that here we have completely dissociated H plus and A minus, but here we have some of the H plus dissociation and B plus dissociation with the presence of HB, that is undissociated one. So this is the concept of the strong acid and the strong base. You can interpret the concepts similarly with that of base. And if you consider this chemical reaction, when this substance is dissociated in water, it produces H plus and A minus. So this is completely dissociated, and this substance is considered as a weak, strong acid. You can write this the dissociation constant of acid, but not equilibrium constant, because this is strong. Concentration of hydronium ion times concentration of A minus divided by concentration of the acid, because this acid is presented as aqueous. Another thing is the equilibrium constant for weak acid, that is this one, which is represented by a double arrow. So you can write the equilibrium concentration for this acid because it is weak. You can say equilibrium concentration of the hydronium ion times concentration of A minus divided by concentration of this acid. And if you see this an example, the dissociation of acetic acid, that is weak acid, in water to produce hydronium and acetate ion, you can write this dissociation constant or equilibrium constant as the product of the produced ion divided by the concentration of the reactant. This is how to express the equilibrium constant for acid. Another thing is expression the equilibrium constant for base. Generally, those bases that contain OH and when dissociated in water to produce the cation and the anion. So you can write this equilibrium constant of base as concentration of product B plus times concentration of OH minus divided by the concentration of the base, that is BOH. So this is all about today's lesson. You are expected to calculate if the concentration of a given acid and a given base is given. So this is all about today's lesson. See you next time. Bye bye. Thank you.